Lecture 2 of Chapter 3, Trapezoidal Rule. So learning outcomes for today's lecture will be students should be able to use the trapezoidal rule to approximate definite integral. So let's look at the graph. Okay, the first graph is the shaded region, the area of A. So it can be divided into n number of strips here. Okay, the width of each strip is h, meaning b, the n value minus a over n. So n will be, n is number of strips. So please take note that for n plus 1 ordinates, there are n number of strips. So it will be illustrated below here. So if 6 ordinates, n is 5. So 6 sub-intervals, n is 6, 6 strips, n is also strips. Okay, the area under the curve is actually sum of the areas of the n number of trapezium. So these are the formula, how the formula is derived. So what you need to remember is the integral from a to b of fx dx is equal to h over 2 bracket y0 plus yn plus 2 times bracket of all the y's in between, where h is b minus a over n, and n is actually number of strips. So we can use either the word strips, sub-interval, or ordinate. So the difference between the three, we can look here. So 6 ordinates and 5, 6 sub-intervals, and 6 strips, and 6. Okay. Example 10. Use the trapezoidal rule with 5 ordinates to evaluate integral of exponent x squared dx from 0 to 0.8. Give your answer correct to 3 decimal places. So 5 ordinates, so meaning n equal to 4. So h equal to 0.8 minus 0 divided by 4. So we have 0.2. So we have the table here. So this is your xn. So this is your yn, which is the function itself, which is exponent of x squared. So we start off with 0. x0 is 0. So x1 is 0.2. x2 0.4. x3 0.6. and x4 0.8. So the last row will be total. So press your calculator. So this is 1.000. So we want 3 decimal places. So you give your values in your table during workings to 4. You need to give it extra 1 decimal places. So this is y0. Okay, this is y1. So this is 1.0408. y2 1.1735. y3 1.4333. And then y4 is 1.8965. So you add up. So here you get 2.8965. And here you get 3.6476. So hence, integral from 0 to 0.8 of exponent of x squared dx equal to half times 0.2, which is the H, and 2.8965 plus 2 times 3.6476. So we have it to be 1.01923 decimal places. Example 11. Approximate integral of surd 1 plus x dx from 3 to 5 by using trapezoidal rule with 4 strips. Give your answer correct to 4 decimal places. So 4 strips, hence n equal to 4. So find your h. So h will be 5 minus 3 over 4. So we have 2 over 4, so 0.5. So we have a table here. So this is your xn. So this is your yn, which is fx. That will be surd of 1 plus x. Alright, so x0 start with 3. x1 will be 3.5. So this is 3.0. So x2 will be 4.0. x3 is 4.5. And then x4 will be 5.0. So the last row again will be total. So press your calculator. So how do you use the calculator? So we have shown you during the first video on how to use the calculator. Okay, so write down the value for y0. So that will be 2.0014 decimal places. So in the working should be 5 decimal places. So y1, so copy down, so get 2.12132. So y2 will be 2.23607. So y3 is 2.34521, and then y4 equal to 2.44949. Okay, so add up. So we will have it to be 4.44949. So this column also you add up to get 6.70260. Right. Once you get those values, so integral of surd 1 plus x dx from 3 to 5. So you just substitute into the formula. Make sure it's the correct formula. So half times h, which is 0.5. And then 4.44949 plus 2 times 6.70260. So press your calculator again. So you get the answer to be 4.4637. This is up to 4 decimal places. So that's your answer. Example 12. Using the trapezium rule with 4 sub-intervals, calculate the approximate value for the area under the curve of fx equals to ln of x plus 1 between x equal to 2 and x equal to 4. Give your answer to 4 decimal places. So 4 decimal places, 4 sub-intervals, so n equal to 4. So your A will be 2, your B 4, your N 4. Okay, so H will be 4 minus 2 divided by 4. So 2 over 4, so we have half, 0.5. So plot the table. So this will be the values for your x. This is value for your y. So y equal to fx. So our fx is ln of x plus 1. So x0 will be 2. x1 will be 2.5. x2 3. Put it 0 there. So x3 is 3.5. x4 4. So this is total. So now press your calculator. So use the table. Okay. And then you can simply write down, copy down the value. So we want 4 decimal places. So inside the table should be 5 decimal places. So this is 1 point, this is y naught. So this is 1.09861. So this is y1, this is y2, this is y3, y4. So y4 is 1.60944, 4 decimal places, 5 decimal places. So this is 1.25276, 1.38629, and 1.50408. So you total up the value. So here we will get 2.70805. So here will be 4.14313. Then we use the formula. So integral from 2 to 4 of ln of x plus 1. So that is equal to half of h 0.5. So the total to 2.70805 plus 2 times 4.14313. So press your calculator. So we will get 2.7486 to 4 decimal places. Example 13. Given that the fx is a continuous function, so you are given the values already as if you're using the calculator. So you need to use the values given and the trapezoidal rule to approximate the value of the integral correct to 2 decimal places. So it's either you plot the table again or retabulate. So whether you use the table, so you use the table like this, is what we used earlier. Okay. So the easier for us to see which is which. So this is your x0, x1, x2, x3, x4, x5. So y0, y1, y2, y3, y4, y5. So remember the first and the last. So since we have x5, so meaning our n is 5. Okay. So the first and the last you need to add up, and then we have the intermediate in between. So you can just simply write down. So your n is 5, your h will be, so if you look at the question, so 0.5 minus 0 divided by 5, so we get 0.1. Okay, so meaning our integral from 0 to 0.5 of fx, we are not given the fx, so you just need to use the value given. So half of h 0.1. So and then we take out the value, so y0 plus y5, so 0 plus 0.8244 plus 2 times of the intermediate value 0.1105 plus 0.2443 plus 0.4050 plus 0.5967. So just press your calculator. So we have 0.18 to 2 decimal places. Right, example 14. So this is the last example for chapter 3. So using the trapezium rule to estimate the value of integral tangent x dx from 0 to pi over 3 with 4 strips again, okay, correct to 4 decimal places. So 4 strips, so n equal to 4. So find your h, so h will be pi over 3 minus 0 over 4, so we get pi over 12. So make sure change the mode into radian, because this is trigo function, so it must be the mode in radian. If not, everything will be wrong. Right. So again, so the first column will be your xn. So this is yn, which is your fx. So for this case, your fx is tangent x. So start off with x0, that will be 0. So x1, so you get pi over 12. So x1, x2 will be pi over 12 plus pi over 12. Pi over 2 pi over 12, that is pi over 6. x3, so x3 will be pi over 4. Okay, and then x4 plus add up with pi over 12, so we get pi over 3, and then the last row will be total. Okay, so press your calculator, okay, into the function table. So the value is 0.00. Okay, so just write down there. So this is y0, which is 0.000. So we want 4 decimal places, so give it to 5. So y1, that is 0.26795. So y2 is 0.57735. y3 is 1.0000, and then y4 will be 1.73205. So add up the total. So this is 1.73205. So here will be 1.84530. Alright, so integral of tangent x dx from 0 to pi over 3. So that is equal to half. Your h is pi over 12. So input the total value there for the first column or the second column. So 1.73205 plus 2 times 1.84530. So the answer will be 0.7098. That is to 4 decimal places. Done. So that is the end of chapter.